So this video will check out problem number 1, part A, from the 2012 AB calculus exam. It was on the BC exam as well. It's a calculator problem, and the situation that's posed is that there's water in a tub and it's being heated over time. We know what the temperature of the water in the tub was at certain values of T as the water is being heated. And we're asked in part A here to use data in the table to estimate what W prime of 12 is, show computations, and then use some units to try and describe what that means. So in this situation, W of T is the function that represents the temperature of the water at any time T. So that's measured in degrees Fahrenheit, and T is being measured in minutes. And if we want to estimate the value of a derivative, which is something you've probably done a decent amount of, you're going to hopefully recognize that a derivative value is an instantaneous rate of change, or the slope of a tangent line at a given point, where an average rate of change is the slope of a secant line. Slopes of tangent lines, slopes of secant lines are going to be relatively close together as long as your secant line contains the point of tangency. So if you look at this list of t values here, 12 would sit smack dab in between 9 and 15. What we can do is we can say the slope of the tangent line to the graph of W at 12, or the derivative of W evaluated at 12, can be approximated by connecting this ordered pair on the graph of W with this ordered pair on the graph of W with a secant line, and then finding its slope. So W prime of 12 is approximated with the difference in the y values, or the difference in the function values, over the corresponding difference in x values, or in this case t values. So in this numerator, I think what you're going to get is 6.1. If you do that subtraction, then that's going to be 6 in the denominator. It's definitely a calculator problem, so I already tossed this into my calculator a minute ago. And on the AP calculus exam, you should round everything on the calculator section to the third digit beyond the decimal, or truncate it. So we could go 1.01. If I truncate it, I'd toss a 6 here next. I'm going to go with the rounded form of that answer, 1.017. And then the units here, which it does ask us for, the units are going to be just units of slope on this graph. Think about what you have as the units of these. These are measures of degrees in Fahrenheit, and then these in the denominator, 15 and 9, those are measured in minutes. So this would be measured in degrees Fahrenheit over minutes, or degrees Fahrenheit per minute. And I'm not going to really write out what this means because it takes a little bit long for me to write on this when I'm recording these videos, but we'll kind of explain it right now. At t equals 12, the instantaneous rate of change of the temperature of the water in the tub is 1.017 degrees Fahrenheit per minute at the 12-minute mark.